Good morning, students. Welcome to the yet another lecture of Advanced Green Manufacturing System, and we are today going to talk about the factorial experiments, continuing on the previous design of experiments and factorial experiments and how it is to be used in the course specifically. And we have seen the experimental setup and why the factorial design is an important design and all those aspects. But we have not done an example, and what we are going to do today is do an example, work out a problem which will give you how the problem, when you get the numbers, when you actually go collect the data, get the data in a particular format, then how will you solve the problem? And once you solve the problem, how will you identify what is to be done and how would you interpret that results? That is what we will be covering in today's topic. So, if you look at the today's agenda, it is factorial experiments part 2. And we have already gone through the introduction to factorial design. We have seen what is the factorial and why is it important thing. We have seen the interaction between factors, why the interaction between factors are important, and we also saw the means and the effects model, means model and effects model. We have seen that already. Okay. And then we also talked about what is the 2 factorial design and why is the 2 factorial design is important. So, we have seen the setup of the 2 factorial experiment, 2 factorial experiment. Okay. We already seen that, and we now going to work on, today we will cover, work an example. Okay. And then mostly statistical software is used. Okay. It can be, examples will be Excel. Okay. Some people use SAS, some people use R, some people will use SPSS, those kind of things. Okay. So, any one of them can be used to study to do a 2-factor experiment and analyze the data. But today we will do the manual work so that you can see how it actually works. So, the example that we mentioned earlier in the class, okay, and this is important that I will refresh the example once again to you. Okay. A factory is designing an experiment. We have a factory, consider a factory that is designing an experiment. Okay. And what are we trying to do is, we want to identify the time taken for material removal to make a part. So, how much time it takes to remove the material to make a specific part is what we are actually going to study. And the manager has to select. So, what the thing is, manager has couple of things to do. The first part is to select the material. Okay. What is the material? And there are 3 possible choices. So, in this case you can see the material type, the first part, there are 3 possible choices, material 1, 2 and 3, right. And there are 3 more other choices. There are additional 3 more possible speeds, okay, possible machine speeds. This is the second choice, okay, on which the machine can be operated. So, these are the 45, 70 and 125 are the RPMs that can be that on which the machine can be operated. So, what we are collecting here, the data for all of these data, what we are talking about, okay, this one implies this is the time taken, okay, to machine the part, So, by simple way we can say that smaller time equals to lesser energy consumption or equivalent to lesser energy consumption. Okay. So, you might be interested in having a smaller machining time ideally in this regard. So, we will talk about that later. So, typically in an experimental system, when you are collecting the machining time, this is the way you collect the data. I have mentioned earlier also. So, what does this happens here is, for the material type 1 and for the speed of 45, there are 4 values. 4 values means you made these 4 are the what we can call it as the replication. So, you made 4 different test pieces of material 1 and used it in the machine at 45 RPM and measured the machining time. Okay. Then similarly, if you think about it, in this case, this particular box, you can see that this is another replication, okay, where you used material 3. Okay. Material 3 was used and the RPM is 125, and at that you tested 4 pieces and recorded the machining time. So, this kind of a data table is you create. So, first thing is create such data table, right. So, you are creating such data table to where you capture the data, and so data table where between factors and responses. Okay. So, these are the factors. So, this is your factor 1 and this is your factor 2 and these are your responses. Okay. So, your the responses are as part of this table. Fine. So, with these responses, now the next question is how do we get to the analysis or how do we compute the values. So, the first thing that we need to look into is the computation equations. So, we have already seen the underlying or the governing equations. Equations related to two-factor factorial experiments. We know what the underlying equations or the governing equations are, but manual computations are done using the following equations. So, what we are trying to do is this manual computations, when you want to do it on using a pen and paper, we use this particular equations. Okay. That is we are going to see what are those equations. So, the first equation, the part number 1 is the total sum of squares, total sum of squares. Okay. It is also known as, it is written by sum of squares of total or SST. Okay. This is the usual notation that we follow, and to calculate the total sum of squares we use this equation SST is equal to, okay, it is a summation, it is a 3-step summation, sigma I is equal to 1 to A. Okay. So, I, if you think about this is your factor A, okay, factor A, and your I is indexing from, in this case is 1 to A, and A is 3 here. Okay. So, you have 3 levels for this. Okay. Then sigma I j is equal to 1 to B. Okay. So, that is the second set of factors, which will be this particular case factor B, okay, and the index is from j is equal to 1 to B, and B in this case is also 3, right. So, that is j is equal to 1 to B, and sigma k is equal to 1 to n. K is the replications, right. So, if you think about it, we have the case right here. There are 4 replication for each level. Okay. K is equal to 1 to n. Okay. So, these 3 things, if you do that, then we will say y I j k square. Okay. You square each individual observation. So, the y I j k is, this is your y I j k. Okay. And then from that you subtract what you call as y dot 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 square divided by a times b times n. Okay. So, the y dot dot is, if you take all of these values, all the 36 values as part of this. Okay. Total sum is y dot dot dot. Okay. You sum all of these values, that is your y dot dot. Okay. So, then another factor in this case is the ABN. Sometimes people also denote this with capital N, which is N is the A times B times N. Okay. So, this is the total number of observations that we talk about in this regard, right. So, this is how you calculate the total sum of squares. Then number 2. Okay. So, next one what we calculate is the sum of squares of main effects. Squares of main effects. Okay. This is the second value that we need to calculate. So, in this case there are two factors, the first one is factor A and second one is factor B. So, this is factor A, this is factor B. So, we want to calculate their main effects. So, that is calculated by SS of A, sum of squares of factor A is equal to 1 over Bn, okay, B for the factor J, the column, and N is for the replicates, sigma I is equal to 1 to A, okay, y I dot dot square minus y dot 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 square over A times B times N. So, this value you can see that needs to be calculated once and used repeatedly without calculating again. Okay. So, this is the once you calculate, you keep on using it in all other equations pretty much. So, this y I dot dot is the column thing, the row thing. You have your y I dot dot. So, which means for each row you sum all the values that are available for all the columns. Okay. And that is the sum of squares of A. And now, sum of squares of B, the second factor is 1 over A n. A is the number of levels for the factor A. A n sigma I is equal to 1 to B, okay, and we say y dot j dot square. Okay. So, that is you are indexing on, the index is on j, okay, minus y dot 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 square over A B n. So, this y dot j dot for this index is pretty much, if you look into this, this is your y dot j dot. Okay. So, for each column, for each individual values of I, you sum the columns. Okay. The I and n are indexed. So, these two will tell you the sum of squares of the main effects. Then the third one that we are more interested in doing, or also is important for us, is the sum of squares of the interaction. Sum of squares of the interaction. Interaction is the interaction between A and B, okay, between both factors. Okay. So, with that, what we now need to think about is how do we calculate that. We have already seen the equation earlier, but you can think about it as sum of squares of AB, okay, which means the interaction is sum of squares of subtotals minus sum of squares of A minus sum of squares of B. Okay. So, what we are saying here is that if we can calculate the subtotals in this regard, then from there we already calculate SS of A and SS of B, you subtract them out of it, you should be able to calculate the sum of squares of AB. Okay. The governing equation is hard to compute. Equation is hard for computation. So, we do the subparts of it. So, the SS sum of squares of total, SS of subtotal, okay. The subtotal is given by the equation 1 over n, okay. Now, A and B are gone, okay. The subtotal is 1 over n sigma I is equal to 1 to A, summation of j is equal to 1 to B. Okay. What you are doing is Yij dot square. Okay. So, you are doing this new term Yij dot. We have already seen that what it is in the previous case, and y dot 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 square over A, B and N, right. So, this right term, right hand side remains the same, but this particular term Yij dot square. So, what we are talking about it is, this is the Yij dot. Okay. This whole thing for this entire 4 is the Yij dot. Okay. Fine. So, then this is done. So, now you have the sum of squares of AB can also, once you calculate this using this, then use the subtraction, you will be able to find out. Then the last one we need to do is sum of squares of error. Okay. And again, error equation is also obtained through computation. So, SSE is equal to SST, sum of squares of totals, minus sum of squares of A minus sum of squares of B minus sum of squares of AB. Okay. So, from total, if you subtract the effects of A, the B and AB together, the left out is the sum of squares of error. So, this is also done because SSE equation is difficult to compute manually. Okay. So, what we do is we use this subtraction method to do the same, right. Okay. So, we will move to what we call as the calculations aspect of it. How do we do the calculations? So, the same example is given to you guys, the calculations, and how do we do this? So, the material type is your factor A. Okay. Factor A varies from I is equal to 1 to little a. This is your factor B. Okay. J is equal to 1 to little b. Okay. And then there is the n in between, right. So, the first thing is our calculations in this regard is, so the this side, the column side, okay, what we the row side actually, not the column side. What we are going to do is, this is your yi dot dot. Okay, this is what is going on there in this regard. Then for you, the next thing that you also need to calculate in this particular case is what we call as the, we will add one more column below this, or one more row below this. We call it as y dot j dot. Okay. So, the y dot j dot will be for this particular thing. So, we will see how these values are calculated. Okay. So, for the value of 1, okay, in our case, this much ideally speaking will give you your first value of y I dot dot. Okay. So, this y I dot dot is given by the, if you think about this, so y 1 dot dot, this is for the factor 1, is equal to 130 plus 155 plus 34 plus all the way to plus 70 plus 74 plus all the way to 58. Okay. This whole thing you sum it up and you get the value of this to be 998. Okay. So, this is the first set of value that you calculate. Then the second one you calculate similarly is y 2 dot dot. So, the y 2 dot dot will be these many values. Okay. So, this is your y 1 dot dot, y 2 dot dot will be calculated, will be same thing as 150 plus 188 plus 136 plus all the way to 70 plus 159 plus 126. You sum all of these and you get it as 1300. Okay, is 150 plus 188 plus all the way to 58 plus 45. Okay, that is 1300. Same way, the last one for the third value that we are going to compute is this one, what we call as y 3 dot dot. For the third level, we sum all those values up, and same way 138 plus 110 plus 174 plus 104 plus 168 plus 160 plus 82 plus 60, this much. Okay. And that value will give you what we call as what is it is 1501. Okay. You can see those computations individually when you look into this. All right. So, that solves the first part, where we can actually see what is this yi dot part of it, right. Then the next one is, what we are now going to do is, we are now going to compute what we call as the yj dot, okay, y dot j dot. And how do we calculate the y dot j dot? So, this portion for this particular factor, okay, will give you the y dot 1 dot. So, this is the first level of this factor, which is 1738. Okay. So, how is that calculated? So, y dot 1 dot is equal to 130 plus 155 plus 74 plus 180 plus all the way to 168 plus 160. Okay. That value is 1738. So, that is how you calculate the first set of the column sums. Okay. This is the first set. And the next one what we are going to talk about is this particular case. Okay. The second one, which we call as the y dot 2 dot. So, for this case, the y dot 2 dot is equal to this, for the second value or for the 70 value, is how do you calculate that? That is calculated by 34 plus 40 plus all the way up to 150 plus 139, right. And that sum, if you do, it is comes to 1291. Okay. So, 1291 is the next sum as coming out of it. Then comes the third value that we need to calculate, which is the y dot 3 dot, which is given by this particular set. Okay. That will be y dot 3 dot, and that will be 20 plus 70 plus 82 plus 58 plus all the way to 82 plus 60. If you sum all these values down, you will get it as 770. Okay. So, this 770 is your all the y dot values, right. Fine. So, this gives you both the rows and the column sums. The third one that we need to calculate is the for the subtotals. So, now the thing is, we need to calculate is the next calculate y I j dot. Okay. So, y I j dot is for each replications. So, the y I j dot is calculated in this particular case as the first one is there will be many values, okay, which is y 1 dot. Okay. So, this is your 1 dot. Okay. This value y 1 dot. Okay. That value is 130 plus 150 plus 74 plus 180. So, that is equal to 130 plus 155 plus 74 plus 180, and that gives you 539. Okay. So, this 539 is this particular value in this case, right. Then the next value we can calculate, okay, out of this is, you can take it as the y. So, when you move to this one, it is 1 2 dot, okay, which is these values where we calculate these. Okay. For first one, so it's y 1 2 dot. Okay. 34 plus 40, 34 plus 40 plus 80 plus 75. Okay. You get that values as calculated to be 229. Okay. 229. So, this is your second value. Then the third one that we are going to calculate here is this. Okay. This is y 1 3 dot. Okay. And that value will come to 230 in this case. Okay. You can, this is the sum of these 4 values. Then comes the next column or the next cell. We call this as y 2 1 dot, the next value. and that is the sum of these columns all put together gives you 623. Okay. Then calculates this one, which is the y22 dot. Okay. The sum of these four values gives you 479. Okay. Then the third, which is of the second row, again y23 dot. Sum of these four values will give you 198. Okay. Then the last what you go is this cell, okay, which is a third row, first cell, y31 dot. This gives you the sum of these four values as 576. Okay. Then comes this cell, you calculate them, y32 dot is sum of all these 583, you get this. Then the last one is y33 dot for this cell, which is called as, sorry, my bad, y33 dot, and we get these values to be summed to us 342. Okay. So now we know how to calculate this many values. Okay. So now once we have calculated all those kind of things, then the next major thing that we need to calculate is something called as, so now the one thing that we need to do is y dot 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 is what we need to calculate. So y dot 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 is equal to 130 plus 155 plus all the way to 20 plus 70 plus 74 plus 180 plus all the way to what you call as 150 plus 188, okay, plus all the way to last towards 82 plus 60. Okay. So you sum all these 36 value. Okay. So we can say it as all 36 values are summed together, and that y dot dot comes to 3799. 3799. Okay. So one other way to think about it is, if you sum these guys up, okay, and also sum these guys also up, the value should tally right here. Okay. That is one of the reasons why it is called the sums of yi dot 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 and sorry yi only two dots and y dot j dot should be equal. Okay. Balanced design. Okay. So these sums should sum to, both of them should sum to 3799 in this particular case. So the material type we had the, okay, A is equal to 3, and here you had what you call as B is equal to 3, okay, and using this, and here we had little n, okay, n is equal to 4. Okay. So this is what the values that we have ended up using in this particular case. Okay. Thank you very much for your patient listening.